Close your eyes for a moment and let yourself drift into the infinite expanse above. Picture a sea of stars, shimmering like scattered diamonds across a velvet canvas. This is the Milky Way, our home in the cosmos, a galaxy so vast and mysterious that it has captivated humanity for centuries. But what makes it truly extraordinary is its shape, a flat, spinning disk that stretches across unimaginable distances. Tonight, we'll unravel the secrets of this galactic pancake, a structure so delicate yet so powerful that it holds billions of stars, planets, and untold wonders within its embrace. As we journey through the stars, let the gentle rhythm of the universe guide you into a state of calm and wonder. Where are you joining us from, and what time is it there? Let the night sky connect us as we explore the mystery of the Milky Way's flat structure, a story that will carry you into the deepest corners of space and the quietest moments of rest. Now, let us travel back in time to a moment when the universe was young and the Milky Way was nothing more than a dream waiting to be born. Picture a vast, swirling cloud of gas and dust drifting in the darkness of space. This cosmic nursery, filled with the raw materials of creation, was the birthplace of our galaxy. Over billions of years, gravity began to pull these particles together, slowly at first, but with growing intensity. Like a cosmic dance, the gas and dust spiraled inward, collapsing under their own weight, until a brilliant burst of light signaled the birth of the first stars. These early stars were giants, burning fiercely and briefly, their lives ending in spectacular explosions that scattered heavy elements across the void. These elements became the building blocks for new stars, planets, and eventually, the Milky Way as we know it. Imagine the forces at play: gravity pulling, gas swirling, and stars igniting, all working together to shape the galaxy we call home. This was the beginning of a story that continues to unfold, a story written in the stars and told across the vastness of time. Now, let us turn our gaze to the present, where the Milky Way has taken on a shape as familiar as it is extraordinary. Imagine a vast spinning disk stretching across the darkness of space like a cosmic pancake. This is the Galactic Disk, the heart of our galaxy, where most of its stars, gas, and dust reside. Spanning an astonishing 100,000 light years from edge to edge, this disk is a marvel of structure and scale. Its flat, thin form is a result of the galaxy's rotation, which flattens the material into a wide, swirling plane, much like how a ball of dough spreads out when spun. Within this disk, you'll find a rich tapestry of stars, arranged in a delicate balance of motion and gravity. Unlike the spherical halo that surrounds the galaxy or the dense bulge at its center, the disk is a dynamic, ever-changing region. It's here that new stars are born, cradled in clouds of gas and dust, and where older stars continue their graceful orbits around the galactic center. The disk is also home to the spiral arms, those stunning arcs of light that give the Milky Way its signature appearance. What makes the galactic disk truly unique is its composition. It's a mix of young, hot stars, glowing with blue light, and older, cooler stars that shine with a golden hue. Between them, vast clouds of gas and dust drift, waiting to be ignited into new stellar fires. This disk is not just a collection of stars, it's a living, breathing part of the galaxy, constantly evolving and reshaping itself. As we explore this cosmic pancake, we begin to see how it stands apart from the rest of the Milky Way. The halo, a faint spherical region surrounding the disk, is home to ancient stars and globular clusters, remnants of the galaxy's earliest days. The bulge, a dense, rounded core at the center, is a crowded hub of stars and the supermassive black hole that anchors the entire galaxy. But the disk, it's the stage where the galaxy's most vibrant stories unfold, a place of creation, motion, and endless wonder. And so, as we drift through this flat, spinning expanse, we are reminded of the delicate balance that holds the Milky Way together, a balance of forces, of light and dark, of past and future. The galactic disk is not just a structure, it's a testament to the beauty and complexity of the universe itself. Now, let us step into the grand theater of the galactic disk, where stars perform an eternal dance, choreographed by the invisible hand of gravity. Picture this: billions of stars, each a glowing performer, gliding through the darkness in perfect harmony. Their movements are not random, but follow a rhythm, a celestial waltz that has been playing for billions of years. At the heart of this dance lies the galactic center, a gravitational maestro guiding every star in its orbit. As these stars swirl around the center, they trace graceful arcs, their paths weaving together like threads in a cosmic tapestry. Some stars move swiftly, their orbits tight and fast, while others glide more slowly, their paths stretching far into the outer reaches of the disk. Together, they create a symphony of motion, a ballet of light and gravity that is both mesmerizing and timeless. Imagine a star, born in the dense clouds of gas and dust, emerging as a bright, young dancer. It begins its journey close to the galactic center, where the pull of gravity is strongest. Over time, it drifts outward, carried by the forces of the galaxy's rotation, until it finds its place in the spiral arms. Here, it joins countless others, their collective glow forming the luminous bands that define the Milky Way's iconic shape. But this dance is not without its drama. Stars occasionally cross paths, their gravitational fields tugging at one another, altering their trajectories. Some stars are flung outward, while others are drawn inward, closer to the galactic center. Yet, despite these interactions, the overall harmony of the disk remains intact, a testament to the delicate balance that governs the galaxy. As we watch this celestial ballet unfold, we are reminded of the interconnectedness of all things in the universe. Each star, no matter how small or distant, plays a vital role in the grand performance. Their movements tell the story of the galaxy's past, present, and future, a story written in light and motion, a story that continues to unfold with every passing moment. And so, as we drift through this cosmic dance, we are filled with a sense of awe and wonder. The stars of the galactic disk are not just points of light, they are dancers in a never-ending ballet, a performance that has captivated the universe since the dawn of time. Now, let us turn our gaze to the spiral arms of the Milky Way, those magnificent swirls that give our galaxy its iconic, whirlpool-like appearance. These arms are not just beautiful to behold, they are also bustling hubs of activity, where stars are born and cosmic wonders unfold. Imagine them as vast, glowing rivers of light, winding their way through the galactic disk, each one a testament to the dynamic forces at work in our galaxy. The spiral arms form as a result of density waves, ripples that move through the disk like waves on the surface of a pond. These waves compress the gas and dust that fill the galaxy, triggering the birth of new stars. As the material piles up, it creates bright, dense regions where young, hot stars ignite, illuminating the arms with their brilliant light. Over time, these stars drift away from the arms, but the waves continue, ensuring that new stars are always being born. What makes the spiral arms so striking is their contrast with the darker, quieter regions of the disk. The arms are alive with activity, filled with glowing nebulae, star clusters, and the remnants of supernova. These regions are like cosmic nurseries, where the raw materials of the universe come together to create new worlds. The Orion Nebula, for example, is one such stellar nursery, a place where stars are born amidst swirling clouds of gas and dust. As we trace the spiral arms outward, we see how they curve gracefully, following the rotation of the galaxy. Each arm is a tapestry of light and color, woven together by the countless stars that call it home. The beauty of these arms lies not just in their appearance, but in their role as the galaxy's engines of creation. They remind us that the Milky Way is not a static structure, but a living, evolving entity, constantly renewing itself through the birth of new stars. And so, as we marvel at the spiral arms, we are reminded of the delicate balance that sustains our galaxy. These arms are not just features of the Milky Way, they are its lifeblood, the places where the story of the galaxy continues to unfold. With every star that is born, with every nebula that glows, the spiral arms write a new chapter in the cosmic tale, a tale that we are privileged to witness. Now let us venture into the unseen, into the realm of dark matter, the invisible force that silently shapes the very fabric of our galaxy. Though we cannot see it, dark matter is everywhere, weaving an intricate web that holds the Milky Way together. It is the hidden architect of the galactic disk, the unseen hand that guides the motion of stars and keeps the spiral arms from unraveling. Dark matter does not emit, absorb, or reflect light, making it invisible to our telescopes. Yet, its presence is undeniable. We know it exists because of its gravitational effects on the visible matter around it. Stars and gas clouds move in ways that can only be explained if there is far more mass in the galaxy than what we can see. This mysterious substance makes up about 85% of the Milky Way's total mass, a staggering amount that dwarfs the visible stars, gas, and dust. Imagine the galactic disk as a grand cosmic dance floor, with stars swirling around the center. Without dark matter, the outer stars would move much slower, and the galaxy would lose its delicate balance. Dark matter acts like an invisible scaffold, providing the extra gravitational pull needed to keep the stars in their orbits and the disk intact. It is the glue that binds the galaxy together, ensuring that the spiral arms remain tightly wound and the disk stays flat. But what exactly is dark matter? Scientists are still searching for answers. It could be made up of particles that interact only weakly with ordinary matter, passing through it like ghosts. Or it might be something entirely different, a form of matter we have yet to understand. What we do know is that without dark matter, the Milky Way as we know it would not exist. It is the silent guardian of our galaxy, shaping its structure and guiding its evolution. As we ponder the mysteries of dark matter, we are reminded of how much of the universe remains hidden from our view. It is a humbling thought, one that invites us to look beyond what we can see and imagine the unseen forces at work. Dark matter may be invisible, but its influence is everywhere, a testament to the profound mysteries that still await discovery in the cosmos. And so, as we continue our journey through the Milky Way, we carry with us the knowledge that even in the darkness, there is beauty and order, holding the galaxy together in an invisible embrace. Now, let us turn our gaze to the delicate clouds of gas and dust that drift silently through the galactic disk. These interstellar clouds, often overlooked in the grand tapestry of the Milky Way, are the very building blocks of stars and planets. Picture them as vast, shimmering nurseries, cradling the seeds of future worlds in their ethereal embrace. Within these clouds, hydrogen gas mingles with tiny particles of dust, creating a cosmic soup that spans light years. Though they may appear dark and empty to the naked eye, these regions are anything but lifeless. They are the birthplaces of stars, where gravity slowly pulls the gas and dust together, forming dense clumps that ignite into brilliant new suns. Over millions of years, these clumps grow hotter and denser until nuclear fusion begins, lighting up the darkness with the glow of newborn stars. But the story doesn't end there. The dust within these clouds plays a crucial role as well. Made up of tiny grains of carbon, silicon, and other elements, this dust acts as a cosmic catalyst, helping to cool the gas and allowing it to collapse further. It is within these dusty cocoons that planets begin to take shape, as the leftover material swirls around young stars, forming disks that eventually coalesce into worlds. Imagine these clouds as quiet, peaceful sanctuaries where the universe works its magic in slow motion. They are places of creation, where the raw materials of the cosmos are transformed into the stars and planets that fill the galaxy. And though they may seem distant and mysterious, these clouds are intimately connected to us. Every atom in our bodies, every molecule in the air we breathe, was once part of such a cloud, forged in the heart of a star and scattered across the galaxy by the winds of time. As we reflect on these cosmic nurseries, we are reminded of the delicate balance that sustains the Milky Way. The gas and dust that fill the galactic disk are not just remnants of the past. They are the promise of the future, the raw materials from which new stars and worlds will emerge. And so, as we continue our journey through the galaxy, let us carry with us the knowledge that even in the quietest corners of space, the seeds of creation are always at work, weaving the story of the universe one star at a time. Now, let us venture deeper into the heart of the Milky Way, where a hidden giant lies in wait. At the very center of our galaxy, shrouded in mystery and cloaked in darkness, resides a supermassive black hole. This colossal entity, known as Sagittarius, a star, is a gravitational powerhouse with a mass millions of times greater than our Sun. It is the unseen anchor around which the entire galaxy revolves, a silent conductor orchestrating the motions of countless stars. Picture the galactic center as a bustling hub of activity, where stars whirl around this invisible titan at incredible speeds. Some stars orbit so close to the black hole that they complete a full revolution in just a few years, racing through space at millions of miles per hour. These stellar dancers are pulled by the black hole's immense gravity, their paths bending and twisting in a cosmic ballet that defies imagination. Yet, despite its overwhelming pull, the black hole does not consume everything in its vicinity. Instead, it shapes the flow of stars and gas, creating a dynamic and ever-changing environment. The influence of this supermassive black hole extends far beyond its immediate surroundings. It plays a crucial role in maintaining the structure of the galactic disk itself. The gravitational forces it exerts help to keep the disk flat and stable, preventing it from collapsing or dispersing into chaos. Without this hidden heart, the Milky Way as we know it might not exist. It is the unseen force that binds the galaxy together, a cosmic glue holding the stars, gas, and dust in place. But the black hole's story is not one of destruction alone. It is also a source of creation. As gas and dust spiral toward it, they form a swirling disk of material known as an accretion disk. This disk glows with intense heat, emitting powerful radiation that can be detected across the galaxy. Occasionally, the black hole releases bursts of energy, sending shockwaves through the surrounding gas and triggering the birth of new stars. In this way, the black hole is both a destroyer and a creator, shaping the galaxy in ways we are only beginning to understand. As we contemplate the hidden heart of the Milky Way, we are reminded of the delicate balance that governs the cosmos. The supermassive black hole, though invisible and mysterious, is a vital part of the galaxy's story. It is a reminder that even in the darkest corners of space, there is order and purpose, a hidden rhythm that guides the dance of the stars. And so, as we continue our journey through the galaxy, let us carry with us the awe and wonder of this cosmic enigma, a silent guardian at the center of it all. As we drift further into the galactic disk, let us turn our gaze to the star clusters scattered across this vast expanse. These clusters, like cosmic families, are gatherings of stars bound together by gravity, each with its own unique story to tell. Among them, we find two distinct types: open clusters and globular clusters, each offering a glimpse into the galaxy's rich tapestry of stellar life. Open clusters are the younger, more vibrant families of stars, born from the same massive clouds of gas and dust. These stars share a common origin, much like siblings raised under the same roof. They are often found within the spiral arms of the Milky Way, where star formation is still active. Picture them as a group of young stars, glowing brightly and moving together through the galaxy, their light illuminating the surrounding space. Over time, these clusters may drift apart, their stars gradually dispersing into the wider galactic neighborhood, but for now, they remain close, a testament to their shared beginnings. In contrast, globular clusters are the ancient elders of the galactic disk. These tightly packed groups of stars are far older, some dating back to the earliest days of the Milky Way. Imagine them as a tightly knit family, their stars huddled together in a spherical formation, orbiting the galactic center as one. Unlike open clusters, globular clusters are not confined to the disk. They reside in the halo, a vast region surrounding the galaxy. Their stars are densely packed, creating a shimmering ball of light that has endured for billions of years. These clusters are like time capsules, preserving the history of the galaxy's formation and offering clues to its distant past. The differences between these two types of clusters are striking. Open clusters are loose and dynamic, their stars still young and full of energy. Globular clusters, on the other hand, are dense and ancient, their stars old and steady, having witnessed the passage of eons. Yet, both types share a common bond. They are families of stars, united by gravity and the shared journey through the cosmos. As we contemplate these star clusters, we are reminded of the connections that bind the galaxy together. Whether young or old, loose or tightly packed, these stellar families are a testament to the beauty and complexity of the Milky Way. They remind us that even in the vastness of space, there is a sense of kinship, a cosmic bond that links the stars in their eternal dance. And so, as we continue our journey through the galactic disk, let us carry with us the wonder of these celestial families, a reminder of the unity that lies at the heart of the universe. Now, let us turn our attention to the countless planetary systems that dot the galactic disk, each one a potential home to worlds beyond our imagination. Picture this: scattered across the vast expanse of the Milky Way, orbiting their parent stars, are planets of every conceivable kind. Some may be rocky and barren, their surfaces etched with craters and ancient lava flows, while others could be shrouded in thick atmospheres, their skies swirling with storms that rage for centuries. And then there are the gas giants, massive worlds with swirling bands of color, their gravity shaping the very fabric of their surroundings. Imagine a planet bathed in perpetual twilight, its surface illuminated by the faint glow of a distant red dwarf star. Or perhaps a water world, its oceans stretching endlessly, hiding secrets beneath their depths. The possibilities are as vast as the galaxy itself. Each planetary system is a unique tapestry, woven from the threads of gravity, chemistry, and time. Some may host life, thriving in conditions we can scarcely comprehend, while others remain silent, their stories waiting to be uncovered. As we gaze into the galactic disk, we are reminded of the sheer diversity of worlds that exist beyond our own. From scorching hot planets, orbiting close to their stars, to icy bodies, drifting in the outer reaches of their systems, the variety is staggering. These worlds are not just points of light in the night sky. They are entire ecosystems, each with its own history, its own potential for discovery. And as we continue to explore the mysteries of the Milky Way, we are drawn ever closer to understanding the true nature of these distant realms, and perhaps our place among them. Now, let us journey back in time to an era when the Milky Way was not the serene spiral we see today, but a dynamic, ever-changing canvas shaped by cosmic collisions. Long ago, our galaxy was not alone in its corner of the universe. Smaller galaxies, drawn by the irresistible pull of gravity, ventured too close, only to be absorbed into the Milky Way's vast embrace. These ancient encounters were not violent clashes, but rather slow, graceful mergers, like rivers merging into a greater sea. Over billions of years, these collisions left their mark, subtly reshaping the structure of the galactic disk. Imagine a smaller galaxy, its stars and gas swirling in a delicate dance, as it drifted closer to the Milky Way. The gravitational forces between the two galaxies stretched and twisted their shapes, pulling streams of stars and dust into long, luminous arcs. These streams, like cosmic brushstrokes, were woven into the fabric of the galactic disk, adding new layers of complexity to its structure. The stars from these smaller galaxies did not simply vanish. They became part of the Milky Way story, their light now mingling with that of our own stars. These mergers also brought with them fresh reservoirs of gas and dust, fueling the birth of new stars and enriching the galaxy with heavier elements forged in the hearts of ancient suns. The spiral arms we admire today may owe their beauty, in part, to these long-ago collisions, which stirred the galactic disk and set the stage for the formation of its intricate patterns. Even the halo surrounding the Milky Way, a faint, spherical cloud of stars, bears the fingerprints of these ancient encounters, as remnants of smaller galaxies continue to orbit in its depths. As we reflect on these cosmic collisions, we are reminded that the Milky Way is not a static entity, but a living, evolving structure shaped by the forces of gravity and time. Each merger, each encounter, has left its mark, contributing to the galaxy we call home. And as we gaze into the night sky, we are witnessing not just the present, but the echoes of a dynamic past, a testament to the ever-changing nature of the universe. As we turn our gaze from the past to the future, the Milky Way's story continues to unfold, a tale written in the language of stars and gravity. Far from being a static entity, our galaxy is on a journey, one that will take it through billions of years of transformation. And at the heart of this cosmic narrative lies a momentous event, a collision that will redefine the Milky Way as we know it. In about 4 billion years, the Milky Way and its neighboring galaxy, Andromeda, will begin a slow, inevitable dance toward one another. Drawn together by the invisible threads of gravity, these two giants will spiral closer and closer, their stars and gas clouds pulled into a cosmic embrace. This collision will not be a violent crash, but rather a graceful merging, a celestial waltz that unfolds over millions of years. Picture it as two great rivers meeting, their waters mingling to form a single, even greater flow. As the galaxies merge, their stars will not collide, for the vast distances between them mean that most will simply pass by one another, like ships in the night. Yet, the gravitational forces at play will reshape both galaxies, stretching their spiral arms into new, intricate patterns. The night sky, as seen from any surviving planets, will transform into a breathtaking tapestry of light, with stars from both galaxies scattered across the heavens in a dazzling display. This merger will also ignite a burst of new star formation, as the gas and dust from both galaxies collide and compress, giving birth to countless new suns. The resulting galaxy, often referred to as Milkomda, will be a vast elliptical galaxy, its light a testament to the union of two cosmic giants. And while the Milky Way, as we know it, will no longer exist, its legacy will live on, woven into the fabric of this new galactic creation. Yet, even as we contemplate this distant future, there is a sense of calm in knowing that the beauty of the cosmos endures. The stars that light our skies today will continue to shine, their light a bridge between the past and the future. And as we drift off to sleep, we can take comfort in the thought that the Milky Way, in all its forms, will remain a source of wonder and inspiration, a reminder of the timeless dance of the universe. Now, let us turn our attention from the bustling galactic disk to the quieter, more mysterious outskirts of the Milky Way, the halo. Unlike the flat, pancake-like structure of the disk, the halo is a vast spherical region that envelops our galaxy like a cosmic haze. It stretches far beyond the disk, a silent and almost invisible presence that holds secrets from the earliest days of the Milky Way. The halo is a place of contrasts. While the disk teems with stars, gas, and dust, the halo is sparsely populated, a realm where stars are few and far between. These stars are ancient, some of the oldest in the galaxy, born in a time when the Milky Way was still taking shape. They drift through the halo like solitary wanderers, their faint light a whisper from a distant past. Among them are globular clusters, tightly packed groups of stars that orbit the galactic center like celestial fireflies. These clusters are relics of the galaxy's youth, containing hundreds of thousands of stars bound together by gravity, their ages often exceeding 10 billion years. The halo is also home to dark matter, the invisible substance that makes up most of the galaxy's mass. Though we cannot see it, its presence is felt through the gravitational pull it exerts on the stars and gas within the halo. This mysterious material weaves an unseen web, shaping the structure of the Milky Way and holding it together. As we gaze into the halo, we are reminded of the galaxy's humble beginnings. It is a place where time seems to stand still, a quiet witness to the Milky Way's long and storied history. And while it may lack the vibrant activity of the disk, the halo holds its own kind of beauty, a serene, almost ethereal quality that invites us to ponder the mysteries of the cosmos. From here, we will journey deeper into the galaxy's heart, where the forces of creation and destruction intertwine in a dance as old as the universe itself. Now, let us shift our gaze from the serene halo to the dramatic and awe-inspiring events that unfold within the galactic disk supernova, the explosive deaths of massive stars. These cosmic fireworks are among the most powerful events in the universe, marking the end of a star's life in a blaze of glory. When a massive star exhausts its nuclear fuel, its core collapses under its own gravity, triggering a cataclysmic explosion that can outshine an entire galaxy for a brief moment. This is a supernova, a spectacle of light and energy that reverberates across the cosmos. The aftermath of a supernova is as fascinating as the explosion itself. In its final moments, the star releases a burst of energy that scatters its outer layers into space, seeding the galaxy with heavy elements forged in its core. Elements like iron, gold, and uranium, essential for planets and even life itself, are born in these fiery crucibles. Without supernova, the universe would lack the building blocks for rocky planets, complex molecules, and the very atoms that make up our bodies. In this way, the death of a star becomes the birth of new possibilities, a cosmic cycle of creation and renewal. The shock waves from a supernova ripple through the surrounding gas and dust, compressing it and triggering the formation of new stars and planetary systems. These shock waves act like cosmic sculptors, shaping the interstellar medium and setting the stage for the next generation of stars. It's a reminder that even in destruction, there is creation, a balance that defines the life and death of stars. As we contemplate these stellar explosions, we are reminded of the interconnectedness of the universe. The elements forged in supernova travel across vast distances, eventually finding their way into new stars, planets, and perhaps even living beings. It's a humbling thought that the very atoms within us were once part of a star that met its end in a brilliant flash of light. From here, we will turn our attention to the remnants left behind by these cosmic explosions, neutron stars and black holes, the enigmatic remnants of massive stars that continue to shape the galaxy in their own mysterious ways. Now, as we venture deeper into the aftermath of these stellar explosions, we encounter the strange and fascinating remnants left behind, neutron stars and black holes. These cosmic oddities are the final chapters in the lives of massive stars, and their existence continues to shape the galaxy in profound and mysterious ways. Neutron stars are the incredibly dense cores that remain after a supernova. Imagine crushing the mass of our sun into a sphere no larger than a city. The result is a neutron star, where matter is packed so tightly that a single teaspoon of it would weigh billions of tons. These stars spin rapidly, some completing hundreds of rotations every second, sending out beams of radiation that sweep across the cosmos like cosmic lighthouses. These beams, when detected from Earth, are known as pulsars, and they provide astronomers with valuable insights into the extreme conditions within these stellar remnants. Black holes, on the other hand, are even more enigmatic. When a star's core collapses under its own gravity and no force can stop it, a black hole is born. These regions of space are so dense that not even light can escape their gravitational pull, making them invisible to direct observation. Yet, their presence is felt through their influence on nearby stars and gas. As matter spirals into a black hole, it heats up and emits intense radiation, creating some of the brightest phenomena in the universe. Black holes also warp the fabric of space and time, bending light and distorting the paths of objects that venture too close. Both neutron stars and black holes play a crucial role in shaping the galactic disk. Neutron stars, with their powerful magnetic fields and rapid spins, can accelerate particles to nearly the speed of light, creating high-energy environments that influence the surrounding gas and dust. Black holes, particularly the supermassive ones at the centers of galaxies, act as cosmic anchors, governing the motion of stars and gas on a grand scale. Their gravitational pull can trigger the formation of new stars or even entire star clusters, weaving a complex tapestry of creation and destruction. As we ponder these cosmic oddities, we are reminded of the delicate balance that governs the universe. From the explosive deaths of stars to the birth of neutron stars and black holes, each event is a thread in the intricate fabric of the galaxy. These remnants, though born from destruction, continue to shape the cosmos, ensuring that the story of the Milky Way is one of endless transformation and wonder. Now, let us drift into the realm of possibility, where the boundaries of space and time stretch before us like an endless canvas. Imagine, for a moment, what it would be like to journey through the galactic disk, gliding past stars and planets, that have remained untouched by human presence. This is not just a flight of fancy, but a dream that has captivated the minds of scientists, explorers, and dreamers alike. Picture yourself aboard a spacecraft, its sleek design cutting through the vast expanse of the Milky Way. Outside your window, the stars shimmer like distant lanterns, their light traveling millions of years to reach your eyes. Each star you pass holds the promise of new worlds, some with swirling atmospheres of gas, others with surfaces of ice or rock. The galactic disk, with its flat, pancake-like structure, stretches out in all directions, a sea of light and shadow that invites you to explore its mysteries. As you travel deeper into the disk, you might encounter a star system with planets orbiting in perfect harmony. One planet, bathed in the warm glow of its sun, could have oceans of liquid water and skies filled with swirling clouds. Another might be a barren world, its surface scarred by ancient impacts, yet holding secrets of its own. The diversity of these worlds is a testament to the creativity of the universe, each one a unique masterpiece in the grand tapestry of the galaxy. The journey through the galactic disk would not be without its challenges. The vast distances between stars would require technologies far beyond our current capabilities, perhaps harnessing the power of light itself or bending the fabric of space and time. Yet the rewards would be immeasurable. To stand on a distant planet, gazing up at a sky filled with unfamiliar constellations, would be to experience a sense of wonder that transcends time and space. As you continue your voyage, you might pass through regions of the disk where new stars are being born, their light piercing through clouds of gas and dust. These stellar nurseries are places of creation, where the raw materials of the universe come together to form new suns and planets. Witnessing such a moment would be like watching the universe itself come to life, a reminder of the endless cycle of birth and renewal that defines the cosmos. And then, as your journey nears its end, you might find yourself approaching the edge of the galactic disk, where the stars begin to thin and the darkness of intergalactic space looms ahead. Here, the Milky Way reveals its true scale, a vast island of stars adrift in an even greater ocean of emptiness. It is a humbling sight, one that reminds us of our place in the universe and the infinite possibilities that lie beyond. Interstellar travel may remain a dream for now, but it is a dream that inspires us to look beyond the horizon and imagine what could be. As we drift off to sleep, let us carry this vision with us, a reminder that the universe is not just a place to be studied, but a frontier to be explored. And who knows, perhaps one day, the dream of traveling through the galactic disk will become a reality, and we will find ourselves among the stars, discovering the wonders that await us. As we venture further into the mysteries of the galactic disk, one question lingers in the vast silence of space. Are we truly alone? The possibility of alien civilizations existing within the Milky Way is a thought that has fascinated humanity for centuries. With billions of stars and countless planets scattered across the galactic disk, the odds of life existing elsewhere seem almost inevitable. But what would such life look like, and where might we find it? To begin, let us consider the conditions necessary for life as we know it. Water, a stable atmosphere, and the right temperature range are often seen as the building blocks for life to thrive. Within the galactic disk, there are countless star systems with planets orbiting in what scientists call the habitable zone, the perfect distance from a star where liquid water could exist. These worlds, often referred to as Goldilocks planets, are neither too hot nor too cold, offering the potential for life to take root and flourish. But life, as we have learned, is remarkably resilient and adaptable. It might not always resemble the forms we are familiar with on Earth. Imagine a planet where life thrives in the icy depths of subsurface oceans, or in the dense, swirling clouds of a gas giant. The galactic disk, with its vast diversity of environments, could harbor life in ways we have yet to imagine. From microbial organisms to intelligent beings, the possibilities are as endless as the stars themselves. The sheer scale of the Milky Way adds another layer of wonder to this question. With hundreds of billions of stars, each potentially hosting its own system of planets, the chances of life existing elsewhere are staggering. Yet, the distances between these stars are equally immense. Even if alien civilizations do exist, the challenge of detecting or communicating with them across such vast expanses of space is daunting. This is where the search for extraterrestrial intelligence, or SETI, comes into play. Scientists use powerful telescopes and advanced technology to scan the skies for signals that might indicate the presence of intelligent life. But what if we are not alone? What if, somewhere within the galactic disk, another civilization is gazing up at their night sky, wondering the same thing? The thought is both humbling and exhilarating. It invites us to dream of distant worlds where life has taken a different path, where cultures and societies have evolved under alien suns. Perhaps one day, we will find evidence of these civilizations, and the universe will feel a little less lonely. As we ponder the possibility of alien life, let us not forget the beauty of the unknown. The galactic disk, with its countless stars and planets, is a reminder that the universe is full of surprises. Whether or not we ever find proof of extraterrestrial life, the search itself is a testament to our curiosity and our desire to connect with the cosmos. So, as you drift off to sleep tonight, let your mind wander among the stars and dream of the distant worlds that might one day reveal their secrets. Now let us journey back in time, not through the stars, but through the stories and myths that ancient cultures wove around the Milky Way. For as long as humans have gazed at the night sky, the band of light stretching across it has inspired wonder, reverence, and imagination. To our ancestors, the Milky Way was not just a collection of stars. It was a canvas for their dreams, fears, and beliefs. In ancient Greek mythology, the Milky Way was said to have been created by the goddess Hera. According to the legend, when the infant Hercules was brought to her to nurse, she pushed him away, and her milk spilled across the heavens, forming the glowing path we see today. This story, filled with both beauty and tragedy, reflects the Greeks' attempt to explain the celestial wonder above them. It reminds us that even in the distant past, people sought to find meaning in the cosmos. Meanwhile, in the myths of the indigenous peoples of Australia, the Milky Way was often seen as a river or a pathway. The Yolngu people of northern Australia believed it to be the resting place of their ancestors, a celestial river where spirits traveled after death. This connection between the stars and the spiritual world highlights the deep reverence many cultures held for the night sky, seeing it not just as a physical phenomenon, but as a bridge between the earthly and the divine. In Norse mythology, the Milky Way was known as the Bifrost, a shimmering bridge connecting the realm of the gods, Asgard, to the world of humans, Midgard. This bridge, guarded by the god Heimdall, was said to be the path that warriors traveled to reach Valhalla after a heroic death. The idea of the Milky Way as a bridge or pathway is a recurring theme across cultures, symbolizing a connection between worlds, both real and imagined. The ancient Chinese, too, had their own interpretation of the Milky Way. They called it the Silver River, and it played a central role in the story of the cowherd and the weaver girl, a tale of love and separation. According to the legend, the two lovers were banished to opposite sides of the Silver River, allowed to meet only once a year when a bridge of magpies formed across the stars. This story, still celebrated during the Kixi Festival, reflects the enduring human desire to find romance and meaning in the heavens. As we reflect on these ancient myths, we are reminded that the Milky Way has always been more than just a scientific curiosity. It has been a source of inspiration, a mirror reflecting the hopes, fears, and dreams of countless generations. These stories, passed down through the ages, connect us to our ancestors and to the timeless wonder of the night sky. So, as you look up at the Milky Way tonight, remember that you are part of a long tradition of stargazers, each finding their own meaning in the stars. As we leave behind the ancient myths and stories that have shaped our understanding of the Milky Way, we step into the realm of modern astronomy, where technology and curiosity have unlocked the secrets of the galactic disk like never before. Today, the tools at our disposal allow us to peer deeper into the cosmos, revealing the intricate details of our galaxy's structure and the forces that shape it. One of the most remarkable advancements in this field has been the development of powerful telescopes, both on Earth and in space. Instruments like the Hubble Space Telescope and the James Webb Space Telescope have given us breathtaking images of the Milky Way's spiral arms, star-forming regions, and even the supermassive black hole at its center. These telescopes, equipped with advanced sensors and cameras, can capture light from distant stars and galaxies, helping astronomers map the galactic disk with incredible precision. But it's not just about seeing farther. Modern technology has also allowed us to listen to the galaxy. Radio telescopes, such as the Very Large Array in New Mexico, detect radio waves emitted by celestial objects, revealing hidden features like clouds of gas and dust that are invisible to optical telescopes. This has led to groundbreaking discoveries, such as the identification of vast molecular clouds where new stars are born, and the mapping of the Milky Way's magnetic field, which plays a crucial role in shaping the galactic disk. Another key tool in modern astronomy is spectroscopy, which allows scientists to analyze the light from stars and other objects to determine their composition, temperature, and motion. By studying the spectra of stars in the galactic disk, astronomers have uncovered clues about the galaxy's history, including how it formed and evolved over billions of years. This has revealed that the Milky Way is not a static structure, but but a dynamic, ever-changing system, with stars and gas swirling in a complex dance around the galactic center. Perhaps one of the most exciting discoveries in recent years has been the detection of exoplanets, its planets orbiting stars outside our solar system. Thanks to missions like NASA's Kepler and TESS, we now know that the galactic disk is teeming with these distant worlds, some of which may have conditions suitable for life. This has opened up new questions about the possibility of life elsewhere in the galaxy and has fueled our ongoing quest to understand the universe. Yet, despite all these advancements, the Milky Way still holds many mysteries. Dark matter, for instance, remains one of the greatest enigmas in modern science. While we cannot see it directly, its presence is inferred from the way it influences the motion of stars and gas within the galactic disk. Unraveling the nature of dark matter is one of the key challenges facing astronomers today, and it could fundamentally change our understanding of the universe. As we continue to explore the galactic disk, each discovery brings us closer to understanding the Milky Way's secrets. But with every answer comes new questions, reminding us that the cosmos is a place of endless wonder and discovery. So, as we gaze at the night sky, let us marvel not only at what we have learned, but also at the mysteries that still await us, waiting to be uncovered by the next generation of stargazers and scientists. As we turn our gaze from the cutting-edge tools of modern astronomy, let us step outside and look up, where the Milky Way reveals itself in its most timeless form. On a clear, dark night, far from the glow of city lights, the Milky Way stretches across the sky like a river of stars, a luminous band of light that has captivated humanity for millennia. This breathtaking sight is our galaxy seen edge on, a cosmic ribbon woven from the combined glow of billions of stars, gas, and dust. Imagine standing beneath this celestial canopy, where the air is crisp and the sky feels infinite. The Milky Way arches overhead, its soft glow painting the heavens with a delicate, silvery light. Here and there, dark patches interrupt the glow. These are vast clouds of interstellar dust, obscuring the light of stars behind them and adding texture to the galaxy's luminous tapestry. It's a reminder that even in the vastness of space, there is both light and shadow, beauty and mystery. For countless generations, this view has inspired wonder and reflection. Ancient cultures saw in the Milky Way a pathway for spirits, a bridge between worlds, or the spilled milk of a divine being. Today, we understand it as the plane of our galaxy, a flat disk of stars and gas that we see from within. Yet, knowing the science behind it doesn't diminish its magic. If anything, it deepens our appreciation, connecting us to the vast, intricate dance of the cosmos. As you gaze at the Milky Way, let your mind wander. Each point of light is a star, some similar to our sun, others vastly different. Some of those stars have planets orbiting them, worlds we may never visit, but can still dream about. The faint glow you see is the combined light of countless suns, some of which may have burned out long ago, their light still traveling across the void to reach us. It's a humbling thought, reminding us of the scale of the universe and our small but significant place within it. The Milky Way's beauty is not just in its appearance, but in what it represents, a connection to the cosmos that transcends time and space. It invites us to pause, to breathe, and to marvel at the wonders above. Whether you're an avid stargazer or someone who rarely looks up, the sight of the Milky Way can stir something deep within, a sense of peace and belonging to something far greater than ourselves. As we prepare to explore the next chapter of our journey through the galaxy, let this moment linger. The night sky, with its shimmering band of light, is a reminder that the universe is not just out there. It's a part of us, a story written in starlight that we are privileged to witness. And as we continue to uncover its secrets, we carry with us the quiet awe of standing beneath the Milky Way, a timeless symbol of the beauty and mystery of the cosmos. Now let us turn our attention to the rhythm of the galaxy itself, a cosmic cycle that unfolds over millions of years. Just as Earth experiences seasons, spring's renewal, summer's abundance, autumn's change, and winter's stillness, the galactic disk too has its own seasons, a grand dance of creation and quiet that shapes the life of the Milky Way. Picture the galaxy in its springtime, a period of vibrant star formation. Vast clouds of gas and dust, stirred by the gravitational pull of passing stars or the shock waves of supernova, begin to collapse under their own weight. Within these cosmic nurseries, new stars ignite, their light piercing through the darkness like the first blooms of spring. These young stars, hot and brilliant, illuminate their surroundings, carving out glowing cavities in the interstellar clouds. It's a time of energy and growth, a season of birth that fills the galaxy with fresh light. But as with all seasons, this burst of activity gives way to a quieter phase. The galaxy's summer is a time of stability, where stars settle into their orbits and the pace of star formation slows. The interstellar medium, once teeming with activity, grows calmer, like a field after the harvest. Yet even in this stillness, there is beauty. The stars shine steadily, their light weaving a tapestry of constellations that tell stories of the galaxy's past. Then comes the galactic autumn, a time of transition. Older stars, having burned through their fuel, begin to fade or explode in spectacular supernova. These events scatter heavy elements, carbon, oxygen, iron back into the interstellar medium, enriching it for future generations of stars and planets. It's a season of both endings and beginnings, a reminder that even in the vastness of space, nothing is truly lost. Finally, the galaxy enters its winter, a period of relative quiet. Star formation slows to a near halt, and the interstellar medium grows sparse. Yet even in this stillness, there is a quiet majesty. The stars that remain shine with a steady, enduring light, their warmth a testament to the galaxy's resilience. And somewhere, in the depths of the cosmic winter, the seeds of a new spring are already being sown, waiting for the right conditions to begin the cycle anew. This cosmic rhythm, this ebb and flow of creation and stillness, is a reminder of the galaxy's dynamic nature. It's a story of balance, of life and light emerging from the darkness, and of the enduring beauty of the Milky Way. As we reflect on these galactic seasons, we are reminded that even in the vastness of space, there is a rhythm, a cycle, a harmony that connects us all. And now, as we prepare to explore the next chapter of our journey, let us carry with us this sense of cosmic rhythm, a reminder that the universe is not static, but alive, ever-changing, and ever-beautiful. As we drift further into the mysteries of the Milky Way, let us now turn our gaze to the invisible threads of energy that weave through the galactic disk cosmic rays. These high-energy particles, born from the most powerful events in the universe, travel vast distances, carrying with them the secrets of their origins and the stories of the stars that created them. Imagine cosmic rays as messengers, racing through the galaxy at nearly the speed of light. They are not rays of light, as their name might suggest, but tiny particles, protons, electrons, and even the nuclei of atoms, hurtling through space with incredible energy. Many of these particles are born in the fiery hearts of supernova, the explosive deaths of massive stars. When a star reaches the end of its life and collapses in on itself, the resulting explosion sends shock waves rippling through the surrounding gas and dust, accelerating particles to unimaginable speeds. These particles then escape into the galaxy, becoming cosmic rays. But supernova are not the only sources of these energetic travelers. Some cosmic rays are thought to originate from the supermassive black hole at the center of the Milky Way, where immense gravitational forces can fling particles outward with tremendous energy. Others may come from distant galaxies, traveling across the vast emptiness of intergalactic space to reach us. As these particles journey through the galactic disk, they interact with the magnetic fields that permeate the galaxy. These fields bend and twist the paths of cosmic rays, guiding them in intricate spirals as they move. This dance between particles and magnetic fields is a delicate one, shaping the flow of energy throughout the Milky Way. Cosmic rays also play a vital role in the life of the galaxy. When they collide with atoms in the interstellar medium, they can trigger the formation of new elements, contributing to the chemical richness of the galaxy. They also influence the formation of stars and planets, their energy helping to heat and ionize the gas clouds from which new worlds are born. Yet, despite their importance, cosmic rays remain elusive. They are invisible to the naked eye, and their paths are so chaotic that tracing them back to their origins is a challenge. Scientists use sophisticated instruments, like detectors on Earth and satellites in space, to study these particles and unravel their mysteries. As we ponder the journey of cosmic rays, we are reminded of the interconnectedness of the galaxy. These particles, born in the most violent events in the universe, travel across vast distances, shaping the very fabric of the Milky Way. They are a testament to the dynamic and ever-changing nature of our galaxy, a reminder that even in the quietest corners of space, there is energy, movement, and life. And now, as we prepare to explore the next chapter of our journey, let us carry with us this sense of wonder, knowing that the galaxy is alive with energy, both seen and unseen, shaping the story of the Milky Way in ways we are only beginning to understand. Now, let us turn our attention to another invisible force that quietly shapes the structure of the Milky Way, the galaxy's magnetic field. Though we cannot see it, this vast network of magnetic energy stretches across the galactic disk, weaving through the stars, gas, and dust like an unseen tapestry. It is a force that guides, shapes, and influences the very fabric of our galaxy in ways both subtle and profound. The Milky Way's magnetic field is not uniform. It is a complex web of lines and loops, created by the motion of charged particles and the rotation of the galaxy itself. As stars and gas clouds move through space, they generate electric currents, which in turn produce magnetic fields. These fields intertwine, creating a dynamic and ever-changing magnetic landscape. One of the most important roles of the galactic magnetic field is its influence on the movement of gas and dust. The interstellar medium, the vast expanse of gas and dust that fills the galactic disk, is not static. It swirls and flows, driven by the gravitational pull of stars and the energy of supernova, but the magnetic field acts as a guiding hand, shaping the paths of these particles as they move. For example, when a cloud of gas begins to collapse under its own gravity to form a new star, the magnetic field can slow or redirect this process. The field exerts pressure on the gas, resisting its collapse and sometimes even splitting it into smaller fragments. This delicate balance between gravity and magnetism helps determine the size and shape of the stars that eventually form. The magnetic field also plays a crucial role in the formation of spiral arms, those beautiful, swirling patterns that define the Milky Way's appearance. As gas and dust move through the galaxy, the magnetic field channels them into dense, winding streams. These streams become the building blocks of spiral arms, where new stars are born and the galaxy's structure is continually renewed. But the influence of the magnetic field extends beyond star formation. It also affects the movement of cosmic rays, those high-energy particles we explored earlier. The field bends and twists the paths of these particles, guiding them through the galaxy in intricate spirals. Without the magnetic field, cosmic rays would travel in straight lines, escaping the galaxy entirely and leaving behind a quieter, less dynamic Milky Way. Scientists study the Milky Way's magnetic field using a variety of tools, from radio telescopes that detect the faint signals emitted by magnetized gas, to satellites that measure the polarization of starlight as it passes through the field. These observations reveal a galaxy alive with magnetic energy, a force that quietly shapes the destiny of stars, gas, and dust. As we reflect on the role of the Milky Way's magnetic field, we are reminded of the delicate interplay of forces that govern our galaxy. It is a reminder that even the unseen can have a profound impact, shaping the cosmos in ways that are both beautiful and mysterious. And now, as we prepare to delve deeper into the wonders of the galactic disk, let us carry with us this sense of awe, knowing that the galaxy is not only a place of stars and planets, but also of invisible forces that guide its evolution. As we journey further into the mysteries of the galactic disk, let us turn our gaze toward the countless worlds that lie beyond our solar system, exoplanets. These distant planets, orbiting stars far beyond our sun, are a testament to the incredible diversity and wonder of the universe. Each one is a unique world with its own story to tell, waiting to be discovered and explored. The search for exoplanets has revolutionized our understanding of the galaxy. Using advanced techniques, astronomers have uncovered thousands of these distant worlds, each one offering a glimpse into the vast possibilities of planetary systems. One of the most common methods used to detect exoplanets is the transit method. As a planet passes in front of its star, it causes a slight dimming of the star's light. This tiny dip, measured with incredible precision, reveals the presence of a planet and provides clues about its size and orbit. Another powerful tool in the hunt for exoplanets is the radial velocity method. This technique detects the subtle wobble of a star as it is tugged by the gravitational pull of an orbiting planet. By measuring these shifts in the star's light, scientists can determine the planet's mass and distance from its star. Together, these methods have opened a window into the rich tapestry of worlds that populate the galactic disk. The diversity of exoplanets is truly astonishing. Some are rocky worlds, similar to Earth, while others are gas giants, many times larger than Jupiter. There are planets that orbit their stars in mere days, and others that take centuries to complete a single orbit. Some exoplanets are bathed in perpetual daylight on one side and eternal night on the other, while others drift freely through space, untethered to any star. Among these distant worlds, there are those that lie within the habitable zone, the region around a star where conditions might be just right for liquid water to exist. These planets, often referred to as Goldilocks worlds, spark our imagination and raise profound questions about the possibility of life beyond Earth. Could there be oceans, continents, or even civilizations on these faraway planets? The answers remain hidden, waiting for future discoveries to reveal them. As we imagine these distant worlds, we are reminded of the boundless creativity of the universe. Each exoplanet is a unique masterpiece, shaped by the forces of gravity, chemistry, and time. They remind us that our galaxy is not only a place of stars and gas, but also of countless worlds, each one a potential home for life or a new frontier for exploration. The discovery of exoplanets has transformed our view of the Milky Way, revealing a galaxy teeming with possibilities. As we continue to explore the galactic disk, we carry with us a sense of wonder and curiosity, knowing that each new discovery brings us closer to understanding the true nature of our cosmic home. And now, as we prepare to delve into the next chapter of our journey, let us hold on to this sense of awe, knowing that the galaxy is full of mysteries waiting to be uncovered. As we continue our journey through the galactic disk, let us now turn our attention to the fascinating field of galactic archaeology. This cosmic detective work allows astronomers to uncover the history of the Milky Way by studying the ages and compositions of stars scattered across the disk. Like ancient artifacts buried in the sands of time, these stars hold clues to the galaxy's past, revealing stories of its formation and evolution. Each star in the galactic disk is like a time capsule, preserving the conditions of the universe at the moment it was born. By analyzing the light from these stars, astronomers can determine their age, chemical makeup, and even their motion through space. Older stars, for example, tend to have fewer heavy elements, as they formed when the universe was younger and less enriched by the explosions of earlier generations of stars. Younger stars, on the other hand, are often richer in these elements, having formed from gas and dust that had already been seeded by the remnants of supernova. One of the key tools in galactic archaeology is spectroscopy, a technique that breaks down the light from stars into its component colors. This allows scientists to identify the unique fingerprints of different elements within a star's atmosphere. By comparing these fingerprints, astronomers can piece together the chemical history of the galaxy, tracing how elements like carbon, oxygen, and iron have been distributed and recycled over billions of years. Another important aspect of this cosmic detective work is studying the motion of stars. As stars orbit the galactic center, their paths can reveal the gravitational forces that have shaped the Milky Way over time. Some stars move in orderly, circular orbits, while others follow more chaotic paths, hinting at past collisions or interactions with smaller galaxies. By mapping these motions, astronomers can reconstruct the galaxy's history, uncovering the events that have shaped its structure and composition. The Galactic Disk is not just a collection of stars, but a living record of the Milky Way's past. Through the careful study of these celestial time capsules, we can begin to understand how our galaxy formed, how it has changed over time, and how it continues to evolve. This work is a testament to the power of curiosity and the human desire to uncover the mysteries of the cosmos. As we reflect on the stories written in the stars, we are reminded of the deep connection between the past and the present. The light we see today from these ancient stars has traveled across vast distances and through countless ages to reach us, carrying with it the secrets of the galaxy's history. And now, as we prepare to explore the next chapter of our journey, let us carry this sense of wonder with us, knowing that the Milky Way still holds many stories waiting to be discovered. As we turn our gaze beyond the boundaries of the Milky Way, we find ourselves surrounded by a cosmic neighborhood filled with fascinating galaxies. Among these neighbors are the large and small Magellanic Clouds, two dwarf galaxies that orbit our own. These celestial companions are not just distant specks of light, but active participants in the ongoing story of the Milky Way. The large and small Magellanic Clouds are visible from the southern hemisphere, appearing as faint, glowing patches in the night sky. Despite their modest size compared to the Milky Way, they play a significant role in shaping our galaxy's structure. Over billions of years, their gravitational pull has tugged at the Milky Way, distorting its outer regions and contributing to the formation of its spiral arms. One of the most striking interactions between the Milky Way and its neighbors is the Magellanic Stream, a long ribbon of gas that stretches across the sky. This stream was created as the gravitational forces of the Milky Way stripped gas and dust from the Magellanic Clouds during their close encounters. This material now flows through the halo of our galaxy, feeding its reservoirs of gas and dust, and potentially fueling the birth of new stars. The Magellanic Clouds are also home to vibrant star-forming regions, where massive stars are born in brilliant bursts of light. These regions are not only beautiful to observe, but also provide valuable insights into the processes that drive star formation. By studying these galaxies, astronomers can better understand how smaller galaxies evolve and interact with larger ones like the Milky Way. As we continue to explore the Milky Way's neighbors, we gain a deeper appreciation for the interconnectedness of the cosmos. The large and small Magellanic Clouds are more than just distant galaxies. They are part of a dynamic system that shapes and is shaped by the Milky Way. Their presence reminds us that our galaxy is not an isolated island in the universe, but a member of a vast and ever-changing cosmic community. With this understanding of our galactic neighbors, we now prepare to delve into the next chapter of our journey, where we will explore the intricate dance of stars within the Milky Way's disk and the forces that guide their motion. Now let us glide into the heart of the Milky Way's disk, where stars perform an intricate and mesmerizing dance. Each star, from the smallest red dwarf to the most luminous giant, moves at its own unique pace, tracing graceful arcs through the vast expanse of space. This celestial waltz is not random, but guided by the invisible hand of gravity, which orchestrates their paths with precision and elegance. Near the center of the galaxy, stars whirl around the supermassive black hole at breathtaking speeds, completing their orbits in mere millions of years. These stars are like dancers spinning at the center of a grand ballroom, their movements swift and intense. Farther out, in the spiral arms, stars move more leisurely, taking hundreds of millions of years to complete a single orbit. Here, the dance is slower, more deliberate, as if the stars are savoring their journey through the cosmic expanse. The varying speeds of stars create a dynamic and ever-changing structure within the galactic disk. Some stars race ahead, while others lag behind, their paths weaving together in a complex tapestry of motion. This interplay of speeds gives the Milky Way its distinctive spiral shape, with stars clustering in dense regions and thinning out in others. It's as if the galaxy itself is alive, constantly shifting and evolving as its stars move in harmony. Yet, this dance is not without its challenges. Stars must navigate through clouds of gas and dust, dodging obstacles as they travel. Occasionally, they encounter one another, their gravitational fields pulling them into close encounters. These interactions can alter their paths, sending them on new trajectories, or even ejecting them from the disk entirely. Despite these disruptions, the overall rhythm of the galactic waltz remains steady, a testament to the enduring balance of forces within the Milky Way. As we watch this cosmic ballet unfold, we are reminded of the delicate balance that governs the universe. Each star, no matter how small or distant, plays a vital role in the grand performance. Together, they create a symphony of motion that is both beautiful and awe-inspiring, a reminder of the intricate connections that bind the cosmos together. With this vision of stars in motion, we now turn our attention to the faint glow that emanates from the galactic disk, a light born from the combined radiance of billions of stars and the dust that surrounds them. As we shift our gaze to the soft, ethereal glow of the Milky Way's disk, we find ourselves immersed in a cosmic light that stretches across the heavens. This gentle radiance, a blend of starlight and the faint shimmer of interstellar dust, paints the galaxy in hues of silver and gold. It is the collective glow of billions of stars, each contributing its own tiny spark to this vast, luminous tapestry. Imagine standing beneath a clear night sky, far from the glare of city lights. Above you, the Milky Way arches like a celestial river, its glow faint but unmistakable. This light is not the harsh glare of a single star, but the combined radiance of countless suns, their light traveling across unimaginable distances to reach us. Interwoven with this starlight is the faint glow of dust, tiny particles that catch and scatter the light, adding a soft, diffused quality to the galaxy's glow. This cosmic light is more than just a visual marvel. It is a testament to the interconnectedness of the universe. Each photon of light, whether from a distant star or a speck of dust, carries with it a story of creation and journey. The stars themselves, born from clouds of gas and dust, now illuminate those very clouds, creating a cycle of light and life that spans the galaxy. The glow of the Milky Way is not uniform, but varies in intensity and color, reflecting the diverse regions of the galactic disk. In the spiral arms, where star formation is most active, the glow is brighter, tinged with the blue light of young, hot stars. In the quieter regions between the arms, the light is softer, dominated by the cooler, redder glow of older stars and the dust that surrounds them. As we contemplate this cosmic light, we are reminded of the quiet beauty that pervades the universe. It is a light that has shone for billions of years, a constant presence in the ever-changing dance of the galaxy. It invites us to pause, to reflect, and to find peace in the vastness of the cosmos. With this tranquil vision of the Milky Way's glow still lingering in our minds, we now turn to explore how this light has inspired artists, writers, and dreamers throughout history, weaving the galaxy's beauty into the fabric of human culture. As we drift from the celestial glow of the Milky Way, let us now wander through the realms of human imagination, where the galaxy's beauty has sparked creativity across centuries. The Milky Way has long been more than just a scientific marvel. It has been a muse, a source of inspiration for artists, writers, and musicians who sought to capture its ethereal essence in their work. In ancient times, the Milky Way was often seen as a bridge between the earthly and the divine. Greek mythology tells of the goddess Hera, whose spilled milk created the glowing band across the sky. In Chinese folklore, it was the Silver River, separating two star-crossed lovers, the cowherd and the weaver girl, who could only meet once a year. These stories, rich with emotion and wonder, reflect how the Milky Way became a canvas for human dreams and desires. Artists, too, have been captivated by the galaxy's luminous beauty. The Dutch painter Vincent van Gogh immortalized the night sky in his iconic work Starry Night, where swirling patterns of light evoke the dynamic energy of the cosmos. His brush strokes, alive with movement and color, seem to echo the dance of stars within the galactic disk. Similarly, the surrealist painter Salvador Dali found inspiration in the Milky Way, using its imagery to explore the boundaries of reality and imagination. Writers have also turned to the Milky Way as a symbol of mystery and infinity. In his poem, When I Heard the Learned Astronomer, Walt Whitman contrasts the cold precision of science with the awe-inspiring beauty of the night sky, reminding us that the galaxy's true power lies in its ability to stir the soul. Science fiction authors like Isaac Asimov and Arthur C. Clarke have woven the Milky Way into their tales, imagining distant worlds and civilizations that lie within its spiral arms. Musicians, too, have found harmony in the galaxy's vastness. Composers like Gustav Holst, in his orchestral suite, The Planets, evoke the grandeur of the cosmos through sweeping melodies and celestial themes. Modern musicians continue to draw inspiration from the Milky Way, using its imagery to explore themes of exploration, connection, and the infinite possibilities of the universe. The Milky Way's influence on art and culture is a testament to its enduring power to inspire. It reminds us that the galaxy is not just a collection of stars and dust, but a source of wonder that transcends time and space. As we reflect on these creative expressions, we are reminded of the deep connection between the cosmos and the human spirit, a bond that continues to inspire new generations of dreamers and creators. With this journey through art and culture complete, we now turn our gaze to the final chapter of our exploration, where we will reflect on the enduring beauty and mystery of the Milky Way, inviting you to carry its tranquility with you as you drift into peaceful rest. As we bring our journey through the wonders of the Milky Way to a close, let us take a moment to reflect on the breathtaking beauty and profound mystery of the Galactic Disk. This vast, flat expanse of stars, gas, and dust is not just a scientific marvel, but a source of endless fascination and tranquility. Its spiral arms, glowing with the light of billions of stars, remind us of the infinite possibilities that lie within the cosmos. The Milky Way's galactic disk is a place of both order and chaos, where stars are born, live out their lives, and eventually fade away, leaving behind the building blocks for new worlds. It is a cosmic dance, a symphony of light and motion that has captivated humanity for millennia. From the ancient myths that saw it as a bridge to the heavens, to the modern artists and thinkers who find inspiration in its depths, the Milky Way continues to stir our imaginations and connect us to something greater than ourselves. As you drift off to sleep tonight, let the image of the galactic disk fill your mind. Picture its swirling arms, its glowing center, and the countless stars that call it home. Imagine the planets orbiting distant suns, the nebulae where new stars are born, and the quiet, ancient beauty of a galaxy that has watched over Earth for billions of years. Let this vision of the cosmos bring you peace, a reminder that we are all part of something vast and wondrous. Thank you for joining us on this journey through the Milky Way. If you enjoyed this exploration of the galaxy's mysteries, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss a cosmic adventure. Until next time, may your dreams be filled with the stars, and may the wonders of the universe always inspire you. Good night and sweet dreams.